So this slide is making sure that you understand some very confusing vocabulary. We have two main words. Actually, there's four words. You could be talking about a growth factor, or sometimes it's going to be a decay factor. And then sometimes we're going to be talking about a growth rate, or we could be talking about a decay rate. So these are actually two words: growth factor, decay factor, growth rate, decay rate. This is some information that you'll need to add in your notes. I will demonstrate this on the next couple of slides. Um, your fact, and I do want to show you that it talks about these in your textbook. Right here, it talks about the exponential decay factor is going to be a number that's between 0 and 1. It's usually going to be a fraction, or it could be a decimal. And the growth factor is going to be a number that's bigger than 1. I remind you here that it's the multiplier. It's going to be the multiplier on your table. And again, I'm going to show you that over here in just a second. And it can also be calculated. Oh, it's the b in the equation. So when you write the equation right here, it's the base of the exponent. So that's your growth factor if it's a number that's bigger than 1. And it can be calculated if they give you the growth of the decay rate instead of the growth of the decay factor. It can be calculated. Here is the formulas that I'm going to use. Before we get to those formulas, though, I do want to tell you about a rate. A rate is usually going to be given to you in the word problem, where here you'll find the multiplier from a table or from the equation. Here, if it's a word problem, it's going to be given to you as a percentage. Before you do any calculations, you'll want to change that percentage to a decimal. And once you get it changed to a decimal, you can use it to calculate your growth or decay factor. And that's basically what this problem is asking you to do. So if you jump over here real quick, you can see that this has a constant multiplier of 1.2. I do want to remind you that if you're not sure about the multiplier, then just do a few division problems. So in other words, take 1.44 and divide it by 1.2. Divide it by the term in front of it, and you'll see it comes out to be 1.2. Then do the same thing. Take the next term, 1.728, and divide it by 1.44, and it comes out to be 1.2. So take this term right here, divide it by that one, and you'll see that it's the constant multiplier. So we see that the 1.2 is the constant multiplier, so we would call 1.2 the growth factor. If it's written as an equation right here, it would be the base of the exponent, the variable up there, the base of the exponent x. The formula that I gave you on the other page, you take the growth factor, and that's set equal to 1 plus the growth rate. Just subtract 1 from both sides, and you find out that the growth rate is 0.2. That's written as a decimal. So take that 0.2, change it to a percentage, move the decimal 2 places, and that would be, this problem right here would be a growth rate, a 20% growth rate. And that's just the 0.2 written as a decimal. So an example of a word problem here would be the rabbit population is increasing at a rate of 20%. So in this problem right here, they're giving you the growth rate. You would take that growth rate, change it to a decimal, plug that number in right here, add it to 1 plus 0.2, and you get 1.2 as then your growth factor. So you can compute them either way. Where this is an example of, you can see the decay, the values are getting, the y values are getting lower over time. You can see it in the equation, in the table. It changes from a value of 1 down to 0.75, down to 0.5625. It keeps getting smaller. You can also see that this number is a number between 0 and 1. So it is decay. So the decay factor is 0.75. You use the formula that I gave you over here. The decay factor is equal to 1 minus the decay rate. So all I did was say the decay factor, 0.75, is equal to 1 minus the decay rate. So you solve this for decay rate, subtract 1 from both sides, and then divide by that negative, and you figure out that it's 0.25. It makes sense because the 0.25 is what you're taking away from 1 to end up equaling 0.75. That is the decay rate written as a decimal, though, and decay rates are normally reported as a percentage. So you move that decimal 2 places over, and you would say that a decay factor of 0.75 would have a decay rate of 25%. And yes, those two should always go together. 0.25 and 0.75 should equal 1. That's the whole idea. So in an example in a word problem would be the value of the car is decreasing by 25%. So if you're given the decay, and you know it's decay because it's decreasing, if you're given the decay rate, then you take that number, change it to a decimal, subtract that number from 1, and you'll have the decay factor. And then you would be able to use it as a multiplier to figure out your table or to plug it in and get your equation.